that said, I want to introduce Olivia, who has a company, Sisteo. Olivia has been working in, this will just be a brief intro, Olivia. I'm counting on you to give everybody a little bit more background on yourself. But Olivia created Sisteo. It's a newer company and it's really interesting. I really love some of the conversations we've had around this. She also has a deep background in design. And you can see this in her deck and the way that she presents Sisteo to the world. And she also has a pretty comprehensive academic background in some of the topics we're talking about. So I think that this topic in particular is a great way to close off the tech track because it helps to round out some of the decisions we make as technologists who want to build in the best way possible. With that said, it's all yours, Olivia.
Cool. Thank you. I will start sharing my screen.
Oh yeah, I almost forgot to mention, sorry. If anyone has any questions, please feel free to write those into the chat here, and I'll be on the other end trying to help Olivia aggregate those and make sense of those. If I can answer them right away, I will. If not, I'll hold your question until there's a gap, at which point we can ask those questions.
Cool. Thanks, Justin. Yeah, so coding for sustainability. As he mentioned, my name is Olivia Peterson. I'm founder and CEO at Sisteo. Sisteo is an early stage venture and we're on a mission to empower the individual. And we're doing so by creating an application to help people transition to a sustainable lifestyle. So think of this app as a pocket-sized personal guide to sustainability. The people that using it will be able to learn daily tips, set goals for themselves, and then save useful resources all in one place. So a little more background on me. I'm not an engineer. I'm not a software developer. I know how to do light coding. So building a company that's a technology company as a non-tech founder is very interesting. I've really come to the point a lot of days of just knowing how much I don't know what I don't know. So really this is a presentation to be an idea sparker or a curiosity builder for you guys if you are software developers or if you are a leader or just a citizen listening in. This presentation will apply to all of you in some way. So yeah, as Justin mentioned, if you have questions, put them in the chat and then we'll talk through them. I really want this to be an interactive conversation. And so if you have ideas that might be tangents to get into, let's get into them because I think this stuff's really interesting. So how did I start down this rabbit hole of app development and like figuring out, okay, so I'm not building a physical product. That's great. I don't want to make more stuff. I want to build a network. I want to build a communication system. I want to build something for people, a community that can help them live more sustainable lives. So that evolved into the idea of, okay, this needs to be an app, not a website. And then the next question was like, okay, I don't want to create any new problems with this, but I know there has to be a carbon footprint and I know there has to be natural resources used. And what is the ecological effect on ecosystems that this app will create? What are those outputs? So I started down this rabbit hole of what does it mean to make a ecologically minded SaaS product? So I started mapping out Sisteo as I would any other systems thinking approach idea. So business as unusual through a systems thinking perspective. What is the network of Sisteo? And so this network map here shows all of the active agents within this network. So there's the app, of course, there's the user, the device, being the phone, the servers, the brand, the community, and on and on. And so I was like, that's really great, but I still have no idea what the tangibles are of the actual physicalities. Which then led me to, okay, brainstorming, thinking about it. I know it uses internet. Okay, cool. So who invented the internet? And I figured this was a good time to have some trivia. Does anybody know who invented the internet? Feel free to blurt out.
Tim Berners-Lee?
Who'd you say?
Or I was going with Tim Berners-Lee.
Tim Berners-Lee. Yes, but not at this stage. So down the line, he was hired to come in and develop it further, but it started with the US Department of Defense as a RapNet, which used packet switching to allow multiple computers to communicate on a single network. So basically, they were trying to create a private and safe communication system. And that was in 1960. And then Berners came in later to actually develop it out and scale it. And if you guys want to learn more about this, I would suggest going to this vox.com link in the middle, and it has a full comprehensive layout of how the internet evolved. But this led me to the even deeper question of, okay, so did the US Department of Defense really realize what they were creating? No, they had no idea what they were creating would turn into what the internet is today, which led me even further on my march of, okay, I need to try to at least start to conceptualize what the impact of a SaaS product will be. And so using like further systems thinking tools, I built out the user lifecycle diagram. And this is when I really started to be able to make tangibles out of what a SaaS product is. So it starts with the user demand, of course, and that ultimately comes from energy generation. So that is fossil fuels and hopefully renewables, but up until recently, it's mostly been fossil fuels, and that's coal and crude oil. And what we can see in this ecological systems map is that there's 4 main components going on here. So we have our 3 outputs of energy resources, material resources, and that's excluding the device itself. So we're not talking about the phones here, just the physicalities of the app, of the product. The third being the cloud resources, and then the fourth is the outputs. And so those 3 inputs, energy, materials, and cloud, all works through this system to output carbon equivalents. And so to put that into perspective, anybody working in digital products or services is a part of the information and communication technology sector. And within the ITC, to try to give perspective to how big these outputs are, 1% of all electricity generated in the world comes from the ICT. That equals out to 2 to 3% of all the world's emissions. So to put that even further into perspective, that's about the same amount as the shipping sector. So all the physical things in the world being shipped by planes, trains, and automobiles is the same amount of carbon emissions that we creating digital products. So that's wild. That's a lot of GHGs. So more trivia. What do railroads and the internet have in common? Oh no. Okay, so railroad tracks, telegraph lines, and easements. So in my further mission to figure out what the internet is in my non-engineering brain and no training on this, I was like, okay, so where does the internet come from and how did it evolve? So the internet is built upon the old railroad lines that were built back in the day that then evolved into the telegraph lines, which paved the way literally for the fiber optic cable lines that the internet exists on today. And so especially in Southwest Colorado, we might be pretty familiar with easements. Easements are something we have a lot of trouble with in getting high-speed internet to certain places, especially in the San Miguel region. I don't know about any of the other people in the room today, but to give some visual perspective to this is what the railroad network looks like and what it was built on. And these lines are built on the least path of resistance. So this is a map of the lines that are the easiest to cross. And you can see our black hole in the southwest corner of Colorado. There's no easy path to go through in those regions. So looking at the fiber optic network, that's literally what our internet map looks like in the US. And going a step further, and you can see still we've got this huge black hole in our region. And then going a bit further, this is a physical map of what the internet looks like. And these are submarine cables that literally span oceans to connect all of us on the World Wide Web. And so somebody accessing Sisteo app in Sydney, Australia will be using these lines through the South Pacific Ocean, which is wild. That just blew my mind right there. So getting back to, all right, I figured out what the physical impact of this app is going to be. What's the next step? And that is what led me to analyzing cloud cloud hosting providers. And so this is kind of where I'm going to evolve this conversation into exactly how, this is where we're getting into like how you can, as engineers, have a lot, and you guys actually do have a lot of control on your ecological footprint in terms of when you create products. So you're going to start when you're trying to design ecologically minded products, you're going to want to start with analyzing your cloud provider. So here we have the comparison of the three big ones, AWS, Google, and Azure. And as you can see, and as we all know, AWS owns the market share at 30%, Google being the smallest, and then Azure somewhere in the middle. And all of them are working towards some sort of sustainable futures in terms of reducing their outputs and their emissions, but some are doing more than others. I think you can guess who's doing more than others. And I would definitely recommend you go read this article. It's a great comparison on the big three, and it can help you. It will be a vital resource for you guys when choosing who you want to use as your cloud provider when building products. And so the way you would do that when you're running these comparisons, you're going to weigh your company's goals, values, and economics. So, you know, that being affordability with the goals, values, and economics, along with the transparencies of the provider. So a lot of these, especially Google Cloud, has really good information on what they're doing and how they're doing it. And so I think a really good rule of thumb is if there's transparencies, that's a really good indicator that they're actually speaking true to what they say they're going to do. So into development. So there's over 2 billion smartphones worldwide, and there's 60 apps installed on each device on average. So let's times 2 billion times 60. That's a lot of apps being used, and that's a lot of data demand and transfer data demanded and being transferred constantly. So this is a really great case study from WinScribe. And I would encourage you to go read this blog post when you're wondering how much a code mistake could make in terms of carbon emissions. So due to an error in code for this situation, the app ran pointless APIs in the background, calling to the back end, which prevented Android from shutting down the app to save battery life, which doesn't really sound like that big of a deal. But then when they computed it, it outputted to 24 tons of CO2 per year from one single app. So to put this into perspective, how many apps do you guys think are making pointless API calls due to oversight? My guess would be most of them, to be honest. And so it just goes to show like how these little oversights can really have a big impact, but how they're totally fixable. This is another great case study for actual sustainable coding. This is from Wired again, and I would suggest you go read this article. It's about Danny Van Kooten, who developed the WordPress plugin for MailChimp. And he was on a mission to make his life more sustainable, go Danny, and he refactored his plugin to make it more efficient by sending 20 KB less data, which sounds like a very little amount of energy, but then he times that by 2 million websites, and then you times that by the daily users, and that outputted to 59,000 kilograms, and it took him only 2 hours of coding, and it saved 13,000 pounds of CO2. I think that's per day. So that's a very, very large number. So you guys as engineers can think of it in this term. So micro adjustments have macro impacts. Think users times instances times days. So that could be a really easy way for you guys to run an analysis on certain decisions you're making within your code. So here's a list of action items for developers. Code for efficiency, and think of that in terms of energy efficiency. So like that API call study, think about battery power in the device and think about what's going on in the background and if it needs to be going on and when it's going on and why. Think about proximity. So are your servers located in places that make sense for where your biggest demands are? If you have a product that's very heavily used in LA, then maybe your servers should be on the West Coast, not the East Coast, and vice versa. Energy loss over distance is something to always keep in mind. So not only are you using more energy to transmit that data further, but you're losing energy, which then costs more energy to get there. Think about location. So this is a little different from proximity. You can choose where your servers are, and server location climate is huge. So think about Iceland versus Virginia. Iceland and Virginia are both pretty warm in the summer, but in the winter, Iceland is much, much colder. So a lot less cooling efforts will be going into making sure those servers are cooled. So when we think about it, these servers are running 24 hours a day, 7 days a week, nonstop. And that creates a lot of excess heat. And so that heat has to constantly be removed. And there are some places that are using cooling regenerative practices, which is really awesome, but not all are. So it's something to keep in mind and look into. See if there's transparencies on that. Are they using regenerative cooling? And then back to that cloud provider comparison, align with your provider, run a comparative analysis. You're really shopping around here, so be a smart shopper. And make sure you're looking for transparencies. It should be written out on their website what they're doing and how and what their targets are. So if they have a 2030 goal of going net carbon neutral, then you should see if the actual literature follows up on that. And then usage time. So this is more of a gray area and kind of a curiosity sparker, I would call the engineers too here. So servers run 24 hours a day. Is it possible to shut those off? Are there times that you can shut those off? Does it make sense to turn those off at night? It saves money, it saves energy. Would it be a good idea? And then going a step further, can you put this on your users? Would you ask them when they want their off times to be? It hasn't been tested that I know of. I haven't tested it, but it's things like this that are experiment zones that are really interesting to see how they can save outputs. So more into the gray areas. This is a Twitter post that somebody posted calling out this company for maybe greenwashing their cookies. So they're saying the website, the company XYZ was saying, we use cookies to save energy, reduce data transfer, and gather statistics. So is this truth or greenwashing? In my opinion, and to go down another rabbit hole of a thought moment, my assumption is that they are right. They are saving energy because less data transferred inherently equals less energy used, which reduces emissions. So in my unresearched guess, yes, they're not lying. But the only way to be able to tell if that's true or not would be to run a life cycle analysis and compare the energy emissions of the two using cookies versus not using cookies. But there's many other reasons why people use cookies. So this is just like a really good example of maybe areas we haven't thought of before as being big drivers of energy savings. So we use cookies for for different reasons, and energy reductions has never really been considered, but it would be cool to see a study on how much energy would have been lost or would have been demanded and how much emissions would have been created due to us not using cookies for all these years. So just an interesting rabbit hole. So here's a summary of what you guys can do as engineers. Run a cloud provider comparison, think of thoughtful cloud server allocation. Are there places you can experiment? Is turning off a servers, for example, an option? And then how can you code smarter? What 2 hours can you take to your product to implement savings, just like Danny did? Servers on renewable energy. I think between the big three, the only one who's using fully renewable energy at this time is Google Cloud. And the other two are using some renewables along with Rex. And then a big one that we have direct control over is the electricity we use to power our homes and offices. So to get into that further, I'm going to lead into what you can do as a leader or a citizen. And these are things you can do today, literally. So as a leader or citizen, you can sign up for renewable electricity utilities. So for example, in my region, the San Miguel Power Association has a option to go totally renewable. And it only spikes up my energy bill by about $1.94 per month. So you can sign up on your utility bill to go fully renewable. Another thing you can do is, and you can do that for your home and office, and that could create a huge amount of savings. And that would almost, never mind, I'm not gonna get in that rabbit hole. Another thing you can do is go to Ecosia. It's a search engine, so you replace it instead of Google. And what Ecosia does is for every search, I think it's for every search or for every like 10 searches, a tree gets planted. And so thinking about what the value is of that, it's not just about planting trees. Trees are carbon sinks, which means that they eat carbon, taking it out of the air, reducing overall pressures of climate change. So by planting trees, by doing your daily Google searches on Ecosia, you're planting trees, which is creating carbon sinks, which is reducing the amount of emissions in the air. So that's a really simple thing you can do. A third thing you can do is just turn your stuff off. So I think it's like 25% of our household energy bill allocates to devices or appliances that are plugged in but turned off. So that's what we call phantom power. And so 25% of your bill is for all your stuff that you forgot to unplug. So turn it off, you'll save money, save energy. And then ask questions. Always be curious. As a leader, challenge your teams. Maybe it can become an internal thing of how much emissions can we save through sustainable coding and energy efficient coding. Something to think about, and then just really rise to the challenge. And this is kind of a call to action for the engineers in the room. Like, through all this research, I've really realized I didn't understand how much control you guys have and how much power you guys have in terms of savings and reductions. And it's massive. Controlling everything from the provider to where your servers are, et cetera, and the code itself, you guys have a huge amount of impact. And these in my mind, the future of what will shape industries is data and hosting in terms of clouds. So I think you guys have the control in that buying power to shift the demand and what these companies really rise to. So I would just leave you with that note. Here's the resources I used for today's presentation. These are really inspiring books. Inconspicuous Consumption has a really great chapter on internet that does a really deep dive on the first half of what I presented on. And then How Bad Are Bananas by Mike Berners-Lee literally tracks and calculates the carbon footprint of everything from walking through a door to having a baby. So that's a really interesting, fun read. And there's all the links to the case studies. So that's what I have. That's my little nugget of research so far. If you want to keep these conversations going, please get in touch with me. There's my email. Give us a follow. Give Sustainable a follow on Instagram. Our social media is really about giving daily tips to people to reduce and think circular in terms of their daily habits. So give us a follow if you're interested in doing that. And then check us out online and sign up for our newsletter if you'd like to follow us. So if you guys have any questions or want to go back to anything in the presentation, let's do it now.
I love Aaron's comment on the chat. You've inspired one person at least.
I just
switched. I just switched my SMPA bill to totally green with the link you provided in that earlier slide.
Sick. Nice.
I didn't even know that was an option.
Yeah, the thing that's funny about these types of programs is it takes really good marketing to get people to do to sign up. So sometimes that gets missed, but yeah, it's as simple as a couple email signups sometimes.
Yeah, the Azure versus AWS was also really interesting. I definitely have much more affinity to Azure now.
Can we go back to that slide? I kind of had a general question about that slide of comparing the cloud.
Yeah, totally.
I feel like there's more information there that I just didn't absorb. Oh yeah, so everyone, she breezed through her presentation with plenty of time to ask questions, which was the intent. So we can ask away. Yeah.
So the thing I found out, like when I was doing this comparison, was it was interesting to see, number one, who had the market share, which wasn't surprising that it was AWS. But then also number two, the one that had the smallest market share was the one doing the most. And I think that just goes back to scale versus values. And bigger companies have a harder time shifting to these carbon neutral goals, whereas the smaller market share has an easier time. And so it's interesting to see how those pressures can maybe be. I'm not trying to make any excuses for AWS at all, but I can see some sort of correlation there.
But the most unfortunate thing about AWS is sort of what have you done for me recently is they've just poured a whole bunch of money into their Virginia server farm, which was already their least optimally energy efficient, or it had the least green resource of capacity compared to even other servers they have. It's likely addressing their proximity issues, that being their biggest market in the East Coast, but it's nonetheless unfortunate and doesn't align with what their stated goals were.
Virginia is coal powered primarily, right?
I believe so, yes.
I think most of the country is predominantly coal, but
but they do rely heavily on Oregon for West Coast, which I believe is mostly hydro powered. So they score pretty well in Oregon compared to Virginia. But obviously you don't want to serve up to the East Coast all from Oregon for the same issue that Olivia addressed with the proximity.
Yeah, we're actually migrating our stuff from US East 1 to US West 2, which is, I think it's that Virginia to Oregon change. And it works for us because a lot of our services are not user facing, and the ones that are like sites that are served out of CloudFront, so they actually get closer in proximity to users. But yeah, not everyone obviously can move to US West 2, so.
Yeah, it's hard for us because we have a lot of data in S3. We're a media company, and then US East is the only Amazon region that provides free data transfer between S3 and EC2 instances. So we're kind of locked in to US unless we fully move to something like Azure.
Now I know this is a loaded question. I predominantly use AWS for mechanical reasons. Do you guys see big obstacles to moving to something like Azure for your current stack? Your current architectures?
Are you asking me or?
Yeah, anyone who's on the call who cares to respond to such a normal question.
Well, when you have petabytes in cloud storage, there's an egress cost. It'd probably be for us, I think, probably $50,000 to move out. That's like a one-time egress, and then you have all the tooling, I think, is interfaced for the S3 API. Now, there are competitors that are S3 API compatible, like Wasabi Storage is a startup that offers like S3 compatible API storage at a cheaper cost. But I think the main reason is it can be expensive to move a lot of data out. And also all of your code is like ideally it's like only that last little part is what talks to Amazon versus some other provider, but in reality, who knows how tightly coupled it would be. So
That's interesting. So going back to something Olivia said, you know, as developers, we can make these incremental decisions, sometimes even without our management being aware that we're making those decisions, other times not. But like if we prolong those decisions, then we run into kind of what you just described, where it's prohibitive to change to a different solution without putting in significant investment towards that change. I find that really interesting.
yeah, I mean, these companies want you to feel locked in. So in addition to that, once you start being a heavy user of any of them, they're gonna start having you sign annual contracts and stuff. Now, the good news is they also want you to switch. So I bet, for example, if we went to Azure and said we want to move petabytes of media data to your platform, like they might cover our egress costs because now they're getting paid $500,000 a year in storage or whatever. What's interesting though, I wonder, is energy might be one of the biggest cost components of their offering. So like these companies that are more environmentally friendly might also be cheaper. Like it's kind of a win-win. Same with even just developers. Like if you don't care about the environment at all, but your app drains your user's battery, like they're not going to install your app. The incentives are aligned for all players here because of the connection between like electricity usage and cost and battery life with so many people on laptops and mobiles. That's like, I don't know, something that Olivia, I'm curious what you think about the aligned incentives there.
Well, just do you mind if I address one of your kind of egress issues? From a technical perspective, or at least considering how microservices can have nice proxy solutions, reverse proxy solutions, it's sometimes able, depending on your architecture, to migrate things on an as needed basis. So as you're using them, and you can move them and rely on them being in the new place from henceforth, and leaving behind essentially stale assets that you end up realizing didn't need to be moved at all. Now that's possibly speaking to your solution, or maybe not. But it doesn't always have to be an all or nothing. There can be a transition process of moving things that can make it working towards the optimal goal, rather than all or nothing type of situation.
Yeah, it's a great point. Yeah, double dipping, like an egress that happens naturally with just kind of putting it somewhere new is clever.
I think what is always like a pattern that will, in no matter what industry, energy efficiency always aligns with cost effectiveness. So it will always be cheaper to be more energy efficient. But taking those strides, there is a cost curve, if whatever you want to call it, of that initial upfront investment to make that transition. But you have to look at your long-term savings. So what will be the long-term ROI? If this product's going to last 10 to 20 years, I think running cost analysis is really important in terms of when you're looking at making those transitions, to make sure that the gains will pay off. And they will, in terms of by way of energy efficiency.
I'd be really curious. So with that in mind, I'd be really curious, in early stage startup, there's this dangerous mantra that's been floated around for a while: move fast and break stuff, right? I think that was coined by Zuckerberg and Facebook, but I could be wrong on that. But it reminds me of something I see a lot, which is when you're really early stage, you're desperate to build and gain your initial traction and everything, and it's hard to take the long-term view. So I suppose my question with that is, Olivia, do you know of any kind of concise, I feel like you're a bit of a pioneer in this realm, right? And but is there any kind of concise resources that people can turn to make decisions quickly, understanding that in that environment, sometimes you don't even have the ability to ask your management for opinions, or sometimes, you know, the ultimate goal is just making a customer happy.
Yeah. It's really hard because it's multi-layered, you know, decision-making process. And this is something that new, like with startups, it's like with people who are becoming to step in the world of like B Corps, B Corps, people who start their companies as B Corps have a much easier time than people who are an already established company and then try to transfer over to B Corp. So it's like harder to reinvent the wheel than just build the wheel right the first time. But much like the example with how did the internet get invented, like how do we know what we're doing when we don't know where we're going type of thing. So I think just being careful with what you're putting energy of, you know, in terms of just getting products live versus like always coming back to like what are the values and what are the trade-offs of the accelerated timeline. So and it's funny how it really does always come back to the 3 R's: reduce, reuse, recycle, and in this case reduce. So are these efforts reducing our cost efficiencies, or are they reducing our costs? Are they reducing our carbon emissions? Are they reducing our efforts that we have to put into? And that's really what sustainability is. You know, it's not going green. It's what is efficient, what is sufficient, and what can be long-term lasting. And so I think that would be my advice. I don't know of any like quick resources other than just taking the time up front to actually do these comparisons and cost analysis. And it really just comes back to knowing what your company values and what they need to work towards. So if energy efficiency does not outweigh timelines, then, you know, that would be your indicator. And it's just like having those indicators in place and knowing what those are so that you always have these like guiding principles in place to work against. I think is really valuable.
But I think every company does value money, and anybody making a decision on what their AWS bill is going to be, or their G Cloud bill or Azure bill is going to be, management would always like to see the cost benefit analysis of that choice, and that's what I did for the Sisteo's greenfield approach, and I included my own how long it would take me to set up each environment in the way that I was going to be approaching our microservices architectural plan, and you know, using each company's bill analysis tool. How much is it going to cost? Does it go down to the instance per hour rate? How easy is it to cluster, essentially turning things on and off automatically, both from a development perspective and from their availability of service perspective. And each company does go very granular, and I think it does come down to their efficiency of energy resource, and it goes into the billing estimates themselves. So I think just doing that comparison is intrinsically achieving that goal.
And numbers speak, like numbers do the talking. So if you're maybe not you're not the top level, you're doing a comparison to then provide to the CEO or to your higher up, the numbers will do the talking for you. So if you run that cost analysis and it shows that it will save money while still reaching your personal goals of sustainable development, that's 2 birds, 1 stone. And so if you're ever in an environment where upper management does not see energy efficiency as a value, cost analysis will speak for you to that goal.
I have a follow-up question, but I don't want to steal the room. So if anyone else has questions, like, does anyone else have a question before I ask another one? I'm just really into this. So, okay, so I'm not saying you guys are wrong at all. but the question remains blockchain. Yesterday, Bitcoin just hit a high since 2012 or whatever it was, when they had their last high. So the blockchain is kind of back on the map. One of the problems with blockchain in terms of resource usage is the mining. There are literally server farms set up to mine blockchains, and those are very resource intensive. In fact, there's a direct computational power usage for how hard it is to mine an item in a chain. Did you guys jump into that aspect of technology yet? I'm just curious. I know it's complicated.
I'm not sure. Life, can you speak to that?
Have we looked into what? I missed the actual question part.
Have you looked into the renewable aspects or the energy use aspects of blockchains, and in general, just speaking in general, and whether there's any path forward for that to reduce, to have a greener footprint?
I personally have not.
That's interesting though. Next thing to look at.
Yeah, there's a million things, right?
And that's what's so crazy about this like line of research, is that it seems like such an untapped topic that has not really been discussed that much. It's definitely becoming a topic of discussion, but I think in the way that clouds were branded from the beginning, instead of it being explained as a literal physical thing, we've come to believe, especially non-engineer people, non-engineers, we've come to believe that like there's no physical outputs. Like, I'm building an app, I'm not building a physical product. Like, it's just, what could go wrong? What could be the outputs of a non-physical product? And I think so it's like adjusting or like calling out misconceptions is, I think, a vital part of where this line of thought is at right now, and correcting misconceptions.
I think definitely a systems analysis could be done about, the physical minting of money, hauling it around, human effort and counting, et cetera, banking with physical notes versus credit institutions, Visa, Amex, banks using wiring and data transfer of money versus what you're saying, blockchaining and mining. An analysis between the actual costs and effect on the environment could be and would be an interesting study.
Okay, final question, I promise. Have you seen anything about server farms turning that generated heat into actual energy usage or something?
I haven't looked into it too far. I know it's being done in some places, but I know it's not the standard. Yeah, and that's probably all I'm going to say about that, because I haven't really took a deep dive into it just yet.
Yeah, I feel like there's opportunity for someone out there.
Well, it's just totally wasted. It's wasted energy that's not being restored into the process. So it's like looking at things from a non-holistic, like a linear system. Instead of having these outputs be cyclical and going back into the process, they're just releasing that heat and its energy. And instead of seeing that as a resource of like, oh, we could put this back into the system to then use it to cool the system, so it's actually regenerative. It's just been this line of thinking of like, we have this problem, let's get rid of it, instead of like, how can we make limes out of lemons, or what I was saying is, how can we make this actually work for us instead of dealing with it and working against it.
And so that what you just described, is that what you referred to earlier in the presentation around circular thinking?
Yeah. So circular thinking is what Sesteo is calling it. Another great book that speaks to more like physical life cycles in terms of manufacturing is Cradle to Cradle. So that's a framework that's been around for a while of how do we make waste food and how does it go around and around in a system, a cyclical system, instead of being a linear raw to waste. Instead, the waste is actually food for something else, aka that heat could be food for the cooling system to cool itself off. So that's a really great book too, Cradle to Cradle.
I promise that was my last question, even though I asked two. So does anyone else have anything before you wrap up? Yeah, excellent. Well, I want to thank you again, Olivia and Life, for giving this. I know this is obviously, I'm really interested in it. I think this is really intriguing, and it sounds like some of the others on the call also enjoyed it. So thanks a bunch.
Yeah, thanks everyone for your time.
Thank you.